Hello everyone, welcome back to my channel. Today let's go over a medium question that I struggled with for a very long time, and then I thought of something and I tried it and it worked, so came up with my own solution, so I'm really happy about that. I saw one of the other guy's solutions was n squared, so I kind of said, okay, if we can do n squared, then I'll do it my own way, and I did it. So let's go over it. So you're given an integer array ARR and a target, and you basically just want to return the number of triplets that sum the target modulo 10 to the power of 9 plus 7. So pretty straightforward, except if you do it my old way. So just finding all triplets with the indexes have to be less than each other. If ARI plus J plus K is equal to target, increment the result. And then at the end, return result modulo mod, which is just going to be 10 to the power of 9 plus 7. So that's obviously the straightforward approach, but it doesn't really work. So that's K, because you get time limit exceeded because this is n cubed. So I'm going to really try to make it a little bit better. N squared works. So let's go ahead and do that. So time limit exceeded, what you can do instead is basically take pairs and then see if there's a difference between the target and the current pair sum inside of this part of the array. If there is, return the frequency. For example, 1 plus 2 is 3, and then you know that there are 2 5s in here, so you know 2 triplets can be formed, right? 1 triplet here, and then another triplet here for 8. So the trick is just going to be keeping track of the frequencies for all the triplets that we keep expanding towards until we can't. So let's create a counter that's going to keep track. It's going to create a dictionary with all the numbers with their frequencies. And then let's decrement. Let's make a copy of it, because each time, if we don't make a copy of it, I'll show you what happens. So let's see ARRI minus equal to 1. If C of ARRI is equal to 0, then delete it, because if 1 has a frequency of 0, then don't keep it as a key in the dictionary. But if we don't delete this, if we don't have this at the end, we want to reset whatever C is to original, because, for example, if we keep going to the end, then we lose the frequency of all of this. So for example, if our second pointer is here, then we lose all these frequencies, but we want to have those frequencies intact so that we can reuse them later, like this. So then C of ARRJ minus equal to 1. So again, saying we only want, so this is the first pointer, second pointer, the third pointer is going to make up the difference between 8 minus 1 plus 1, which is 8 minus 2, which is 6. So if C of ARRJ is equal to 0, again, delete C of ARRJ. And then this is where the part comes in. So pair sum is equal to ARRI plus ARRJ. So 1 plus 1 is 2. And then the difference is going to be the target minus the pair sum. And if the difference is bigger than or equal to 0, then that means that there's a difference like 6. We're going to try to find that in here, which doesn't happen to exist. But if like this, we're going to try to find 5 in here. How many times does 5 appear? 2 times. So you're going to add 2 to the result. In that case, result plus equals to C diff, because C holds the frequency of all the numbers here, and the diff is the one that we want, similar to 2-sum. And then at the end, obviously, we have to reset C to original, or else we will get errors. Except now it looks like didn't do this quite right. Let's try this. Maybe C.copy. Okay, that's a little better, because if you don't do .copy, then it just, these changes are reflected in original, which is not what we want. And it looks like we can just So we want to add, except we want to divide it by 2, which you get a floating point number, but now the problem is we have to turn this back into an integer, so we're just going to have an array dot append cdiff divided by 2, and then we're just going to return the sum of answer as an integer modulo mod. So because if you keep adding the floats, there's going to be small decimal point errors, but if you do it like this, that's a lot easier. So like 20 goes in the list, for example. Oh, time limit exceeded. So instead of this, we don't even have to do that. We don't have to add result. We just append it directly in there, and that's just enough that I monkey patch this to pass all the test cases. So there you go. So bottom 5%, but hey, it is my own solution and it does work, so I'm pretty happy about that. Hopefully this is not too confusing, but you just have to play around with the test cases until you get it correct, and yeah, make some observations, and that's it. So hope you enjoyed this video and stay tuned for more.